Okay. Okay, I am Marco Mancini. I am a solution architect in OpenNebula system. OpenNebula system is OpenNebula system is the company behind OpenNebula, the open source software. So today I will talk about how you can easily deploy Kubernetes clusters on hybrid and multi-cloud environments by using our open source solution. So let me introduce OpenNebula. OpenNebula was born around 14 years ago as a solution for private cloud computing, for on-premise, and evolved during the last years, and now we provide a solution that allows you to manage different types of workloads, so going from virtual machines to application containers to Kubernetes clusters, along what we call today the data center cloud edge continuum. So you can have resources on-premise, you can have resources on public or on far edge, and so on. So what we would like to do with this open source solution, OpenNebula, is to provide you with a simple way in order to manage different type of workloads along the let's say this cloud edge continuum, and so you can minimize the complexity. To manage these workloads, you reduce consumption of resources because you can manage different types across different kind of resources and so on. So mainly what we at the core of OpenNebula, we use different virtualization technologies. So we go from supporting using VMware, KVM for virtual machine workloads, to LXC for system of containers, to Firecracker, where you can manage micro VMs and deploy container-based applications. And we manage these technologies by using clearly advanced features. You can have multi-tenancy, self-service, so you can provide resources on these different virtualization technologies, and so on. We have a graphical user interface where you can manage all your resources across as I said, this continuum, and also we have integrated different third-party tools, going from Terraform to Ansible to Kubernetes and so on. So our vision about the multi-cloud is that we would like to provide an easy way for automatic provisioning of resources across multiple cloud providers. At the moment, so what we have built is a tool that is called the OneProvision. So you can see in the bottom, so we have also a graphical user interface, but it's also a command line interface. So you can create resources on different providers. At the moment, we support providers that as bare metal servers like AWS and Equinix. But we can support other providers. We just need to write some drivers that allow us to provide resources also across different providers. Behind OneProvision tool, we use open source tools like Terraform and Ansible. So with this tool, with this OneProvision tool, we can build different what we call edge clusters. So an edge cluster for OpenNebula is an abstraction where you have computing, you have storage, and networking. Okay, so once you provide this edge cluster, every edge cluster, whenever is provisioning, can be managed by our uniform, just from one management place, that is our Sandstone graphical user interface, or with our command line interface. And so from one just panel, you can manage all your clusters across different, for example, providers or your premise resources. And then at the end, what we have is the concept of a marketplace. So where you can have appliances, or you can have, we have also integrated Docker Hub, so you can have also Docker images that you can deploy. So you can deploy virtual machine, multi-virtual machine, containers, and Kubernetes clusters across these different different resources, no? That we have provisioned. So this is how we manage, let's say, multi-cloud environment. So by using this one provisioning tool and then our graphical user interface and the marketplace. So let me introduce also how we have built the Kubernetes, how Kubernetes is integrated in OpenNebula. So for us, Kubernetes is just a service. So we have built an appliance. I will talk soon about how we have built this appliance. So as I said, you can manage Kubernetes by using our tool for managing any application, right? So, and then you can deploy on different edge clusters, right? So you can exploit all the features that we have. So if we have, since we have a multi-tenant environment, you can deploy Kubernetes clusters for all your tenants within OpenNebula. So you want to deploy Kubernetes clusters on the same physical resources that are shared. They will be deployed in a secure way because you can deploy by using our virtualization technologies and so on. And also you are not locked into any vendor because you can just deploy your Kubernetes clusters on any, let's say, cloud edge or premise or far edge provider that you would like to integrate within your infrastructure, enterprise infrastructure. So how we have built Kubernetes, integrated Kubernetes in OpenNebula is we have defined an appliance. It's called OneKey. This is just a complete Kubernetes deployment. So it's based on OneKey 2, and we use the version 1.24 of Kubernetes. So we provide all the features. So when you deploy this appliance, you have all the features included. So you don't have to deal with managing deployment of a storage solution or ingress controllers or load balancing. At the moment, we have used these technologies on our roadmap. There are some features that we would like to include, especially a better integration with some of the features that has OpenNebula. But at the moment, yeah, we have this kind of solution that is based on, as I said, on OneKey 2. The OneKey appliance, these are the components, is based on OneFlow. OneFlow is a component in OpenNebula that allows you to define multi-VMs application. So in a OneFlow service, you can have different roles. And each role, for example, in this case, for the Kubernetes appliance, we have defined different roles according, for example, we use the VNF role. This is the load balancer for the control plane, but it also does NAT and routing because we have two networks within our appliance. One is the public network and another is the private network between the different components, okay? So this VNF also allows to go for the different VMs within the private network to communicate outside to the public one. Then we have the master role that his role is to manage the control plane, the etcd database, the API, and so on. Then we have the worker nodes that you can use for any workloads that you want to deploy on your Kubernetes cluster. And then finally, we have the storage nodes. These are dedicated, so they will not be used for when you have to deploy some workloads, but they are used just for your storage needs. And we use long core for persistent volumes within other Kubernetes, within the OneKey service, okay? As I said, the VNF, this virtual network function service, provides a load balancer. So you can have multiple VNF, so in an high availability mode. Take into account that OpenNebula offer you the abstraction of virtual machine groups. So if usually for having an availability solution, if you have a virtual machine, you would like to deploy your virtual machine on different hosts in order to have an available solution. So you can use in OpenNebula VM groups, and then using some affinity or unaffinity rules, your VMs will be deployed, for example, on different hosts, so you can have an available solution. And this is valid for any role that you have seen before. So for any role, you can use these VM groups in order to have also available solution. So OneKey, by default, just create one VM for each role, but you can modify and scale the solution. So having multiple VMs for each role. So this is the VM. As I said, for the persistent volumes, we have this storage nodes where we deploy a Longhorn. We use a Longhorn, so you can have replicas of your volumes, on different VM related to the storage nodes. Then we have, in order to access your services, we need that you deploy within your Kubernetes clusters. You can have the ingress controller you can use. We deploy an ingress controller based on traffic. So this can be used for HTTP and HTTPS protocols. So, and then you can access the service by just defining an ingress for your service. And then we have integrated also MetalLB instead for the load balancer service. So in this case, you can use this for other kind of protocols that are not HTTP or HTTP based. Yeah, I would like to go because, it's almost, I have 5 minutes, more or less. I will prepare just a demo to show you how you can use OpenNebula. So I will show you how to use OneProvision in order to provide resources on AWS and Equinix. And then we can deploy a Kubernetes cluster on both edge clusters that on these two public cloud providers. And then we just can access one of the Kubernetes clusters and just deploy an application. Let me go on the demo. Okay, so this is the Sandstone graphical user interface. So you can see here, if we go to clusters, we have just the default cluster, but there are no hosts, no data. There are only data store, but there are no hosts. So in this moment, we have just our front end without any resources. Now, what I go is to go to the OneProvision. We have defined already two providers, one for Equinix and one for AWS. And once you define these providers, you can create clusters on the two providers. So we are going to create a cluster, for example, in AWS. In this case, we have defined a provider for AWS in London, the zone. And this will now create an edge cluster on AWS. As I said, we use Terraform and Ansible to create resources and to configure in such a way that you create an edge cluster for OpenNebula. And then here I'm going to create another cluster instead of on Equinix. Clearly you have some parameters. You can define the number of hosts. You can define a number of public IP that you would like to access and so on, okay? By the way, you can define two types of clusters with OneProvision. One is an edge cluster, is SS-based, or you can also create a safe cluster, an hyperconvergent cluster. As you can see here, once you use OneProvision in a Sandstone graphical user interface, you will see the hosts that are going to be provisioned. And well, it will take around 5 to 10 minutes. This depends on clearly on the cloud provider, how much time it needs to create resources. But once you have created the resources, you can see here the two clusters. What you have to do is to instantiate a couple of, to use Kubernetes appliance. We have to define a couple of private networks, one for Equinix and one for the AWS clusters. And in order to do this, is simplified because we create a template, then you just instantiate the template, and then you can create also the private networks, both for AWS and Equinix, because we need the private for the internal VMs, the roles like the master, the storage, and the worker nodes, and then we need the public network instead for the VNF. That is our main point where to access the Kubernetes clusters, okay? Now, what we are going to do is to import the OneKey appliance for our marketplace within our OpenNebula, okay? This is, you can done just once, okay? So we are going to import the appliance, okay? And once you import the appliance, what will be imported are templates for the VMs that are for each role, and the template for the service, okay? This service is based on OneFlow, and also the images that are related to the different roles. So in order to create a new Kubernetes cluster, what we have to do is to just instantiate a service by selecting the appropriate networks, for example. So in this case, you can see now I'm creating a cluster on AWS. So I select for the public network, the AWS cluster public, for the private, the AWS private, and then I just have to put a couple of IPs internal. These are for the internal networks, for the virtual IP, for the VNF, and for the gateway. And we can do the same for Equinix. So by just selecting the public networks of Equinix and then the private networks that we have defined. Also in this case, I've used the same network for both clusters. And here you see that now we are deploying the two Kubernetes clusters on the two different edge clusters that are on AWS London and Equinix Amsterdam, I think. As you see, the first role that is deployed is VNF. Once the VNF is ready and running, in OneFlow you can define dependencies. And once the VNF is ready, OneFlow is going to deploy the other roles, master, the worker, and the storage node. In order to access the Kubernetes clusters, you have to use the public IP of the VNF, and you can use SSH agent forwarding by using, first connecting to the VNF, and then connecting to the master by using the private IP, okay? Here we can see the nodes, so we can have, as I said, by default, you have one node for each master. Clear, this is not for production environment. If you wanna have for production environment, you need to scale each node, for example. So here I just create an image, and I prepared also a YAML file, a manifest file, for exposing the service through the ingress controller. And then you can use the public IP of the VNF to access the service, okay? Clearly, OpenNebula is not, doesn't have any tools for managing the deployment of application on Kubernetes. So we manage the infrastructure and the deployment of Kubernetes cluster. Then you can use kubectl, you can use Ranger, you can use other open source tooling, that maybe we can, in the future, we can add also, as you can see here, by using the public IP of the VNF, I have access to the Nginx. Another thing, you can scale the roles once you deploy, for example. In this case, I can scale, for example, the worker. You just put the number here. We use the OneFlow. OneFlow allows us to scale the cluster for each role, okay? And now you can see another worker is going to be deployed. This was the demo, and I think that's the conclusion. Okay, thank you to all. Okay.